started. And so today I think it's my pleasure to invite Dr. Al-Qadi from UAC come here to give a talk. Presentation topic is the future of the flexible pavement sustainability. Let me briefly introduce Professor Al-Qadi. He's a founder professor of engineering at the University of Illinois, Champaign. He's also the director of the Advanced Transportation Research and Engineering Laboratory and founding director of the Illinois Center of Transportation, which is the ICT. Prior to that, he was the professor at Georgia Tech. I mean, sorry, not Georgia Tech. Sorry, Virginia Tech. Well, at Regis, the professional engineer, and Professor Al-Qadi has the author and co-author around 600 publications, and has delivered more than 550 presentations, including numerous keynote lectures. He has led more than 100 projects to complete. In addition, he has managed more than 60 projects annually as the ITC director since 2006. He is the past president of the ASCE, the Transportation and Research Development and Board and governor, and also editor-in-chief of the International Journal of Pavement Engineering. With that, please join me in welcome Dr. Imad.
Thanks for inviting me. It's a pleasure to be here at Georgia Tech. And James asked me about the topic that maybe we should be discussing. I do work in different areas in pavements, including pavement mechanics. I work with ground penetrating radar, and recently sustainability is a big issue in pavements. And we have been working closely with the Federal Highway Administration, and we are working also with Department of Transportation, and also we're working with the tollway in order to find ways how we can improve the sustainability of pavements. And I think for the people who may be interested in this topic, we just recently published as part of a big team for the Federal Highway Administration a documentation. It's called the document on pavement sustainability. And it's a very, very interesting document. It's kind of, I would say, a comprehensive, very thick, yes. He said it's very thick, but it's comprehensive in a way, document, and it's not a guideline, it's more of just to give you directions how things are gonna be and how you should be doing things, but there is no standards or specifications because it's gonna be a dynamic document. So with that, let me start talking about a few things about my thoughts, where we're gonna be going from here, what we have done, and so on. So in my presentation, I will talk a little bit about what is sustainability, the approach to report sustainability, and then talk about the several phases when it comes to the pavements in life cycle assessment, including the materials and processes, maintenance, rehabilitation. And there is an important topic, which is the tire pavement interaction, and that's where most of the energy and most of the emission in pavements. Then I end by sharing with you a tool that we're developing that is the first tool based on regional data for the life cycle assessment. So when we talk about sustainability in transportation, there's so many definitions. I'm going to share with you 3 definitions that I really like. This one here, it allows the basic access needs of individuals as well as communities to meet safely and in a manner consistent with human and ecosystem health and with equity within and between generations, which means here that I don't want to do something here that is going to take from the next generations in the future. The second thing, which is really important, is it has to be affordable and it has to be operated efficiently, and at the same time it gives me the choice between the different modes of the transportation as an individual. And third is the most important thing. We're trying to limit the use of the energy, we're trying to limit the emission, and ultimately try to use as much recyclable and renewable energy as possible. So if I'm going to put all these things together, you will find that we are talking here about our basic needs, we are talking about economy, we're talking about efficiency, we are talking about energy, and trying to do more recycling as well as minimize the emission. So all these things, when we put them together, it will take us to the triple bottom line, which we are talking here about three things. And I do believe that anytime we're trying to do sustainability, if it's not accompanied with economic growth and at the same time taking care of the needs of the society, it will not fly. So that's why we need to make sure that we are working on these three things together. One of the things which is called the Dharma model, I like it here because it simply describes for us the sustainability that we need to have a foundation. Everybody needs to eat and drink, and everybody needs medication, and everybody needs to move from point A to point B. So these are the basic things. And remember, the last point is the one that is related to transportation. So these are the basic needs. And then we have a ceiling, and this ceiling here is the things that we do not want to cross, and that's where we don't want to deplete our resources, we don't want to increase the greenhouse gases and so on. So we can live in peace if we can know where our boundaries here, have the basics, and at the same time make sure that we have the ceiling. So why transportation? If we look at the energy consumption, 28% of the energy is consumed by the transportation systems, but 99% of this energy is related to oil. So that will make the use of the oil by the transportation around 57%. And the United States is using almost 16% of the oil products for the transportation, which is really very, very significant. And most of this, almost 3/4, is related to the trucks, vehicles, and so on. So why is pavement? Pavement, it does affect the fuel consumption at both levels, the infrastructure as well as the use impact, which when people are driving on these pavements. Therefore, there's three approaches in order to look into sustainability in pavements. The first approach here is to come up with a very basic, I would call it qualitative system, where we can give a rating. And INVEST is an excellent program that is developed by the FHWA. Many states, they are trying to use it. And this particular program is just going to give you a qualitative rating. Like I would say it's more like an index. Then we can get this a little further, and we can look into the carbon footprinting, and that's the second stage. And the third stage, which we would like to see ourselves in all the time, is the life cycle assessment. So what is the life cycle assessment? Life cycle assessment is looking at everything from the cradle to grave, and looking at these product system and the processes, and see what is the impact going to be in the environment. In order to do that, it will give us quantification for the environmental impact. It evaluates the improvements that we have in the sustainability, and most important is telling us where the pain points are. So it will tell us where we should be investing more, where we should be working in order to reduce the emission in our pavement system. And again, it will go back to the putting all these three things together. The life cycle assessment is going to give us the impact on the environment. We need to look into the cost, and that's where the life cycle cost analysis will be there. And then also we need to look into a rating system with respect to the society. So all these three now is coming together to make sure that we are looking into the society, we are looking into the economy, and we are looking into the environment. So let's look into the pavement life cycle assessment for the life cycle assessment for pavements. It's like any other system. We're looking into 5 phases. These 5 phases are the materials, then after that the construction, the maintenance, the use, and the end of life. And these 5 phases apply to everything. If we're talking about a can of Coke or we're talking about pavements, we need to look into these 5 phases. Now, for these 5 phases, there is resources, or there is also energy that comes in, and we look into the emission, regardless if it's going to go to the air, the water, or the soil. So we look what's getting in and what's getting out, the upstream and the downstream. So for each one of them, there's a lot that we need to deal with. Materials, for example, we have to deal with the raw materials, transportation, mix, production, construction, transportation, equipment, placement, traffic delay. Same for maintenance, repair, rehabilitation. Use is the most complex one actually, and the least understood is the pavement deterioration, rolling resistance, albedo lighting, and the end of life, which is, are we going to put this material in the landfill, or are we going to be recycling, how much is going to cost us, and the impact on the environment to move it from one place to another. So I'll try to touch on these things as we go. So I'm going to focus more, I guess, on the materials and the use phase a little bit, but I'm going to touch on all of them. So whenever I build a pavement, I want to make sure that this pavement is durable and this pavement is going to perform. Because even if it's sustainable and it's not performing, this means here that I'm going to build it again and I'm now putting more burden in the environment. So performance is important, and that's reduce the maintenance and rehabilitation frequency, as well as providing a smooth surface, and that would reduce also the emission from the vehicles. Then we're going to look into lower impact on the environment, and that's where we can start looking into the recycled materials that we are using, and this can be by using technologies such as warm asphalt, use recycled asphalt pavement, use shingles, and that's not my favorite, so you will know. Concrete recycled materials, or steel slag, and also now we're looking into the biobinder. Now, if I look at projects where the shaded area here is the mixes and what you have above the ground, and the unshaded area here is what's under the ground, and I'm going to start looking here in some sequences showing you how things or how energy is spent in each one of these different ones. Like this one here is paving shoulder removal, paved shoulder remover. This is a granule embankment. This is a pavement removal. This is now different hot mix asphalt or warm mix asphalt that you put on the surface. So if I'm looking at the material production, you can see that the granule embankment here is very significant. If I'm looking at the hot mix asphalt shoulder, it's very significant. And these, by the way, these are real data from a specific project, an interstate highway project. Then I'll look at the material transportation. And when you look here at the pavement removal now, there's a lot of energy went into this particular one here for the transportation. If I look at the plant operation, I don't have much here, right? But I still now have a lot here in the plant operation because that's where I prepare my mixes. Then I have transportation into the site, and that's when you start now adding that one here. It depends on the mixes, how you're going to move things around. That's where the energy is going to be spent. Then the equipment, you can see in this area here is more equipment intensive, while this one is much less. Okay? Then, if I look at the total, which is, again, it's important here, I found that overall I'm not spending that much in this area, but most of it is here. So it's very clear that when I'm dealing with asphalt concrete, there is a lot of energy are there. So where is this energy coming from? Let's go back and look into an illustration here. I got an asphalt plant. The asphalt plant is an aggregate and a binder from a quarry, and these materials, we're going to look into the raw materials, where they came from the first beginning, and process them in transportation and send them there. The plant itself is get electricity. Where this electricity is coming from? What's the different grids? Like, for example, the state of Illinois, we get our electricity from 3 different grids. We need to look at these 3 grids. If you look, for example, at the plant in Illinois, the same plant that you go to Wisconsin, you will find that the emission in Illinois is much less because we are using 70% nuclear. And that's going to be now counted that, hey, you have less emission because there is a nuclear power used. If you are using windmill or solar, that's also definitely going to make a big difference. So that's why we need to look at each case by itself. And then we look into the emission that is coming out of this. Okay, so let's take one of these. I'm going to pick this one and see what is going on there. If I'm going to look into the energy for a hot mix asphalt, everybody, when look at the curve like this, will be surprised. Because the people who are aware or have made asphalt concrete, they know that it's just 5% of the asphalt concrete is asphalt binder. But if you look at this one here, the binder is responsible for almost 40 to 90% of the energy. So this is significant from 5% that is controlling almost the energy that you are getting for the asphalt concrete. So why is this? So if I'm going to go back again and look into the binder itself, I'll find that there is a lot of energy goes into the flaring and the extraction of the crude oil. There is more energy go into the transportation of this. There's more energy when I go to the refineries and separate these crude oils into the different gasoline, kerosene, asphalt binder, and then send it to the storage area of the binder. So these are very extensive, energy extensive processes. Then there is another thing here is, if we're going to divide now the United States into 5 regions in according with the Petroleum Administrative for Defense District, and I'm going to just look into this area and I'm going to compare it to another area. And look, what is the difference here? For example, if I look into the Midwest and I look where they are getting their oil from or their asphalt from, we'll find that 58% of that is coming from Canada, 57% is from the United States, and then just small amounts coming from Algeria, coming from Middle East, from Angola, and so on. And if I look now into the Gulf Coast, I'll find that significant oil is coming, or more, is coming now from the Middle East, which means here that you're going to have much more energy that is going to be spent to get this oil into the United States. Now, this is the model that we developed. This model here, if you look at it, it's going to be involving all the processes from the extraction to the flaring, to the transportation, to the storage. Very, very detailed model. And this model is really allow us now to see the difference between the different regions within the United States. The alternative for us was, when we started the work, is to look into something that is already exists, such as the model from Europe, Sweden, or Finland. And without going through the details, you can see that these models here, they do not look into the details, and the less you look into the details, you will not be able to have accurate results. And you can see here the difference, big difference between the different regions. So the whole idea of the life cycle assessment is data and accurate data. And these processes will be changing with time. For example, if I look at the equipment that we use in the construction, you will find that the emission changed over the past 15 years by almost 70% reduction. So if I use my data based on an equipment from 2010, it's going to give me completely different data when I use the equipment for creating this information from 2015. So it's all about using data to develop the right models for it. So if I look here, for example, about the energy from producing materials for 1 ton of a specific hot mix asphalt, and by the way, this one has 30% recycled materials, and this is a real mix that we got from a plant. So when I looked at this, you can see that there is big variations between the different models that are developed, and it depends where you are using this. For example, if it's in the Midwest, that's the right one for it. But the most important thing here is using the correct data is crucial, because you can see that there is a variations between these models by more than 50%. Okay? So a lot of people, they try to use recycled materials in the mixes. And my opinion here, you can use recycled materials in the mixes if you get the performance. So at least to get advantage of this energy savings and the less emission, you need to make sure that the performance is the same or better, or you're going to be looking at what's the impact going to be in the performance. For example, if I look at this, just a snapshot like this, the more recycled material I use, the less energy and of course less emission. These two in the top are special mixes using stone mastic asphalt, so they're very high in polymer and fibers. So you can see here that with this, if I'm using here 60%, I'm saving energy 20%, which is significant, and 22 of the CO2, which is also very significant. But again, the key point here is to make sure that we have the performance. So if I'm going to look into the different types of surface mixes, for example, between these mixes, you can see that they look nice. These two here, boy, this is the OGFC. I think we use that in Georgia. We do not use it in Illinois because of weather things. And you use also SMA mixes. Now, if you look at these two, they are a little more energy intensive. But where this energy is coming from, it's mainly transportation. Because you need to make sure that you have the right product for the material and the polymer and so on. One of the things that I was working on is to use warm mix asphalt. And one of the materials used in the warm mix asphalt, one of the polymers used, or the additives used in the warm mix asphalt, it was very energy intensive material. And that really was kind of bringing the energy much higher than the lower temperature that you're getting from the warm mix. So we need to be very careful with that. So let's look here into maintenance rehabilitation very quickly too. One of the techniques that's used for rehabilitation, and some people consider it also as part of the preservation, is hot in place technique. And just to make sure that people who are not familiar with this technique, all what you do, you have a train of vehicles. These vehicles, they heat the asphalt. And when it's heated, the asphalt now becomes very soft. And you bring a scarifier, and this scarifier now kind of like take this asphalt. Sometimes they add to it. In this particular case, you're not. You just add additives, and you just put it back and compact it. Okay? So this is completely 100% recycled. We have a project actually, it's going actually two projects. One project is looking at how the performance of this in the field, and the second